According to the National Electrical Code, specifically Article 310.15, conductors and conduit not longer than 6 feet, which is 1.8 meters, are not subject to derating. However, Article 310.15c2 states that conductors and conduit longer than 6 feet, which is 1.8 meters, but less than 24 inches, which is 610 millimeters, shall be derated in accordance with Table 310.15c2. In a situation where the conduit is between 8 to 9 feet in length, which is 2.4 to 2.7 meters, this length is longer than the 6 feet, or 1.8 meters, threshold. Therefore, based on National Electrical Code requirements, the conductors in this conduit must be derated in accordance with Table 310.15c2. This table provides specific derating factors based on the number of circuits within the conduit for lengths up to 24 inches or 610 millimeters. However, for conduit lengths such as 8 to 9 feet, which is greater than 24 inches or 610 millimeters, you still need to apply derating factors based on the number of circuits. The National Electrical Code requires derating for any conduit length longer than 6 feet, regardless of whether the conduit is part of a complete system. To ensure compliance and safety, you should derate the conductors in your conduit according to the provisions outlined in National Electrical Code Section 310.13c2. Specifically, derating factors are as follows. Firstly, if you have 3 circuits within the conduit, the derating factor is 80%. Secondly, if there are 4 circuits, the derating factor is 70%. Thirdly, for 5 circuits, the derating factor becomes 60%. These factors must be applied to the ampacity of the conductors to determine the allowable current carrying capacity. It's essential to understand that derating is necessary because multiple current carrying conductors in a conduit generate heat. The more conductors present, the greater the heat buildup. If this heat isn't managed, it can damage the conductor insulation, potentially leading to short circuits, ground fault, or even fires. The National Electrical Code provides these derating factors to mitigate such risks and ensure that the conductors operate within their safe temperature limits. In practice, this means that after determining the appropriate ampacity for the load you intend to serve, you must then multiply that ampacity by the derating factor corresponding to the number of circuits in the conduit. The resulting value is the maximum current you can safely allow to flow through those conductors. For example, if you have a circuit requiring 30 amps and you're running 3 such circuits in the same conduit, you would multiply 30 amps by 80%, resulting in a maximum allowable current of 24 amps for each circuit. This adjustment ensures that the conductors don't overheat, maintaining the integrity of the insulation and preventing potential hazards. It is important to note that derating factors are cumulative. If other conditions exist that also require derating, such as high ambient temperatures, you must apply all applicable derating factors to determine the final allowable ampacity. High ambient temperatures can further reduce the heat dissipation capability of conductors, requiring additional derating to prevent overheating. When installing conductors and conduit, it is important to follow best practices for wire pulling. This includes using appropriate pulling lubricants to reduce friction and prevent damage to the insulation. Overly tight bends or excessive pulling force can compromise the integrity of the conductors and increase the risk of insulation failure. Proper sizing of the conduit is also crucial. The National Electrical Code specifies the maximum number of conductors that can be installed in a given size of conduit. Overfilling the conduit can restrict airflow, leading to increased heat buildup and necessitating further derating. When making connections within junction boxes or panels, ensure that all connections are properly torqued. Loose connections can create hot spots, which can overheat and potentially cause fires. Regularly inspect electrical systems to identify any signs of overheating, such as discolored insulation or melted components. Addressing these issues promptly can prevent more serious problems from developing. Remember that electrical work should always be performed by qualified individuals who are knowledgeable about the National Electrical Code and other applicable standards. Improperly installed electrical systems can pose significant risks to both property and life. Always consult with a licensed electrician or electrical engineer when in doubt about any aspect of electrical installation or maintenance. Keep in mind that local jurisdictions may have additional requirements or amendments to the National Electrical Code. It's important to check with your local building department to ensure compliance with all applicable regulations. Derating is a critical aspect of electrical safety, and understanding the requirements outlined in the National Electrical Code is essential for ensuring the safe and reliable operation of electrical systems. By following these guidelines, you can minimize the risk of electrical hazards and protect your property and those who occupy it. Always prioritize safety and adhere to all applicable codes and standards when working with electricity. Furthermore, selecting the correct type of conductor for the application is paramount. Conductors are rated for specific temperature ranges, and using a conductor with an inadequate temperature rating can lead to premature failure, especially when derating is required. Ensure that the conductor's temperature rating meets or exceeds the maximum operating temperature expected within the conduit. Consider using conductors with high temperature ratings, such as 90 degrees Celsius, even if the terminations are only rated for 75 degrees Celsius. This provides an additional margin of safety and can help to mitigate the effects of heat buildup. When dealing with multiple circuits in a single conduit, it's also beneficial to balance the loads as much as possible. Unevenly loaded circuits can create unbalanced currents, which can lead to increased neutral currents and additional heat generation. Distributing the loads evenly across the circuits helps to minimize these effects and improve overall system efficiency. In addition to the derating factors specified in Table 310.15c2, it's important to consider any other applicable derating factors that may apply to the installation. For example, if the conduit is exposed to direct sunlight or is located in a high-temperature environment, additional derating may be necessary to account for the increased ambient temperature. Always consult the National Electrical Code and other relevant standards for guidance on applying all applicable derating factors. Proper labeling of conductors and circuits is also essential for safety and maintenance. Clearly label each conductor at both ends to indicate its purpose and circuit number. This helps to prevent confusion and reduces the risk of accidental contact with energized conductors. Use durable, weather-resistant labels that are designed for use in electrical environments. Regularly inspect the labeling to ensure that it remains legible and intact. When making splices or terminations within junction boxes or panels, use only approved connectors and methods. Ensure that all connections are tight and secure to prevent overheating and potential failures. Follow the manufacturer's instructions for installing connectors and making terminations. Avoid using substandard or unapproved connectors, as these can compromise the safety and reliability of the electrical system. Proper grounding and bonding are also critical aspects of electrical safety. Ensure that all metallic components of the electrical system, including conduits, enclosures, and equipment, are properly grounded and bonded to provide a low impedance path for fault currents. This helps to prevent electric shock hazards and reduces the risk of fire. Regularly inspect grounding and bonding connections to ensure that they remain intact and effective. In areas where corrosion is a concern, use corrosion-resistant connectors and materials. Applying a protective coating to connections can also help to prevent corrosion. Consider using stainless steel or other corrosion-resistant materials in harsh environments. When working with aluminum conductors, use connectors and termination methods that are specifically designed for use with aluminum. Aluminum expands and contracts more than copper, and using incompatible connectors can lead to loose connections and overheating. Apply an antioxidant compound to aluminum conductors before making connections to prevent oxidation and improve conductivity. Furthermore, consider the impact of voltage drop on the performance of electrical circuits. Excessive voltage drop can cause equipment to operate inefficiently or even fail. Calculate the voltage drop for each circuit and ensure that it is within acceptable limits. Use larger conductors or reduce the circuit length to minimize voltage drop. The National Electrical Code provides guidance on voltage drop calculations and recommendations. When installing conduit, follow best practices for supporting and securing the conduit. Use appropriate hangers, straps, and clamps to support the conduit at regular intervals. Ensure that the conduit is securely fastened to prevent movement or vibration. Avoid over-tightening clamps, as this can damage the conduit. When routing conduit through walls or floors, use appropriate sleeves or bushings to protect the conduit from abrasion. Seal penetrations to prevent the spread of fire and smoke. Follow all applicable building codes and regulations for conduit installations. Moreover, consider the impact of electromagnetic interference or EMI on sensitive electronic equipment. Ground and shield electrical circuits to minimize EMI. Use shielded cables and connectors to reduce the radiation of electromagnetic energy. Locate sensitive equipment away from sources of EMI, such as transformers and motors. The National Electrical Code provides guidance on grounding and shielding electrical systems to minimize EMI. When working with hazardous locations, such as areas where flammable gases or vapors are present, use equipment that is specifically designed and approved for use in those locations. Follow all applicable codes and standards for hazardous location installations. Use explosion-proof enclosures and wiring methods to prevent ignition of flammable substances. Regularly inspect hazardous location installations to ensure that they remain in compliance with applicable requirements. Also, consider the impact of harmonics on electrical systems. Harmonics are distorted waveforms that can cause overheating of conductors, transformers, and other equipment. Use harmonic filters to reduce the levels of harmonics in electrical systems. Monitor harmonic levels regularly and take corrective action as necessary. The National Electrical Code provides guidance on harmonic mitigation. Regular maintenance and testing of electrical systems are essential for ensuring their continued safe and reliable operation. Perform routine inspections, testing, and cleaning of electrical equipment. Replace worn or damaged components promptly. Keep accurate records of all maintenance and testing activities. Follow a preventive maintenance program to minimize the risk of failures. Ensure that all electrical personnel are properly trained and qualified to perform their duties. Provide ongoing training to keep personnel up to date on the latest codes, standards, and best practices. Encourage a culture of safety and continuous improvement. Regularly review safety procedures and practices to identify areas for improvement. Promote open communication and feedback to encourage personnel to report potential hazards or concerns. Furthermore, consider the use of energy-efficient lighting and equipment to reduce energy consumption and lower operating costs. Use light-emitting diode, or LED, lighting which consumes significantly less energy than traditional incandescent or fluorescent lighting. Install occupancy sensors to turn off lights in unoccupied areas. Use high-efficiency motors and drives to reduce energy consumption. The National Electrical Code provides guidance on energy-efficient electrical design and installation. When designing electrical systems, consider the future needs of the facility. Provide adequate capacity to accommodate future growth and expansion. Install spare conduits and wiring to facilitate future modifications or additions. Plan for flexibility and adaptability to meet changing requirements. Stay informed about the latest developments in electrical technology and codes. Attend industry conferences, workshops, and seminars to learn about new products, techniques, and best practices. Subscribe to industry publications and online resources to stay up to date on the latest news and trends. Network with other electrical professionals to share knowledge and experiences. By following these additional considerations and best practices, you can enhance the safety, reliability, and efficiency of electrical systems. Remember to always prioritize safety and adhere to all applicable codes and standards. Continuously strive to improve your knowledge and skills to provide the best possible electrical services.